continue the contract management series, and today's video is about forecasting raw material prices. Personal disclaimer before we go too much further is I did run at one time a 100% speculative trading operation for a Fortune 20 company. So I am familiar with some of the tools, and I'm very familiar with some of the issues associated with managing time series analytics for EBITDA related issues. So the benefits, I want to illustrate how predictive analytic time series results are available from low cost Excel and Power BI, although we're going to be using the Excel version of that. Just by way of background, when you go into ChatGPT and say, walk me through forecasting methodologies for procurement folks, what you end up is something that looks like this, stratified this way. I don't want to bore you with the top stuff. You can read that, but machine learning, predictive analytics skills are not found in procurement folks. And I would say in general, I would agree with that. And what we're going to walk through here is that doesn't necessarily need to stay that way. We've got some good results here for folks. We're going to go do some conventional stuff that for 85% of the world is completely adequate and will do the job. Then we're going to talk about what very good looks like. And essentially what we're doing is availing ourselves of an optimization tool inside Excel called Solver. We're going to set up a series of parameters, and then we're going to populate the model. And then we're going to close with the math underpinnings of the forecast tool, because I think folks need to know the quality of the tool that Microsoft has made available to folks. First, data sources. There are really excellent no-cost sources available. This is from the St. Louis Fed, and you can see up here on my screen, I've got a FRED icon. Download the thing. You go to the admin. It'll illustrate how to load the tool on, and you can have. They literally, the St. Louis Fed has literally hundreds of data series, and we're going to focus on copper because copper is a great industrial commodity. They call it Dr. Copper. It has great forecasting attributes, and I won't go into all the reasons why. Basically, get the code. You set your filter when you want the data series to start. You go up here to FRED and hit Get Data, and it will populate the series. That's the good news. It's easy. Data series are curated. They're clean. The bad news, they're a little late. Let's talk about good enough. For many people, this is good enough. It means you go to this data set and you go insert, recommended charts, and you all know how to do that. And out comes the chart. You throw a regression on it. And for many people, good enough for budget at work. Okay, for now is we're assuming here a seasonality of 54 months. Copper historically, anecdotally, has had a cycle period of about 4.5 years. So that's okay for now. Pretty good. We're going to do some back testing to see how good that 54 months is. And so we're going to illustrate how to do a back test. But having done that, there are two obvious questions that pop out. So what is the real cycle? And the second one is, so what are the other issues I need to think about? And those are not insubstantial or trivial questions. They're actually quite foundational. So before we go any further, let's replicate what we have here on Pretty Good Work. So we go back to our data set, the cursor here, go insert, go to our forecast sheet, and up comes, I'm sure many of you have seen this. For normal folks, this is a completely worthless chart. There's not much you can do with this. The magic happens here. So let's take this down. Let's put this to 28. That's enough. Let's start our forecast period in 22. That'll give us roughly 24 months. We don't need a confidence interval. Let's get rid of that. Magic starts here. Set manually. And we talked about 54 months. Well, that's the seasonality, so we'll just say 54. So this chart replicates what you saw previously, and you hit create, okay? So we're going to get rid of this because we don't need it. I want to jump right to so we have a process that I want to make available to folks, and I want to walk people through what computing a gap error looks like, the actual versus the forecast. Then we're going to compute the slope error, right? Then we're going to set name ranges, and then we're going to set the solver parameters. Then we're going to run the model, and we'll note the error. What is gap error? What we're doing is we're taking the actual data point, subtracting the forecasted value, and squaring the numbers. So you always have, positive values. Now, we're going to add one more wrinkle to it. We're going to do add a smoothing function here. And this is the sum of the year's digits. So we're going to start at 1, go to 24. And when you look at this one, we're taking the number 2 and we're dividing it by the sum of the period. And so what you end up with, roughly 0.5%. So you can, as you look down through here, what we're doing is we're weighting, the recent events are worth more than the previous event. So now let's set this to 54. And these are the 54 numbers here. Okay. So slope error. Let's talk slope error for a second. Slope error is the regression line that exists between the actual versus the forecast for the backtest period. And so what we have here is a standard error metric that's computed by taking the difference between the means and adjusting by the standard errors. Very slick, and it's got multiple uses in different venues. And cycle month. This is the time period that we used previously, and so this illustration here should look very similar to this illustration here. But at the moment, let's just say that that cycle period is iterated through the forecast model. So you have to enable solver, and what comes up will be something that looks like this. And so the objective function is to what? Well, we want to minimize the gap error, set this to minimize, by changing what? We change our cycle period or cycle month, and that's called the decision variable. Now we insert constraints. We want the month to be, so half of that is 137. We want to set the value itself equal to an integer value. And then we set the minimum, it's got to be greater or equal to 12. Now the slope error needs to be less than or equal to 2.5 or 3. And now we hit solve. Let's go now to, well, this number is 452. Look at the iterations here that are happening. It's already converged on a value of 259. Okay, and let's watch the subproblems. Okay, so we've come up with a solution, and that solution is a 71-month cycle. Fascinating. Let's go look at that. What's happening here? Well, our slope error goes down. That was to be expected. Look at change in the adjustments. You can see the big adjustments here, although we had big numbers here. The valuation was such that for those of you that have got EBITDA impacting activity, this will be helpful. For example, a house builder has got to make decisions about how much copper wire to buy. You know, do you go 1 month forward? Do you go 3? Do you go 6? Do you go 12? Why would you do one versus the other? Well, you should have a point of view about the copper market. Or if you're an intermediary, let's say a scrap recycler, and you're funding the accumulation of copper inside your network, you know, is the trend in copper going up or is it going down? And how far forward should I, you know, how much of it should I hedge or should I not hedge? So there are a whole group of people inside the copper market, both buyers, sellers, intermediaries, that have an interest in getting a sense of what the cycle is. For those people, having a better view of the market matters. Okay. For those folks, I would say you want to use natural logs, and we'll go talk about that. But you don't want monthly data, you want weekly data. So you want faster signals, more granularity, and you want to be ahead of the curve when changes happen. Let's do one more thing here. Let's look at the math underpinnings of the forecast tool. First of all, I want to say that the Microsoft folks have simply outdone themselves with the ETS forecasting tool that's resident in both Excel and Power BI. In my view, it's outstanding. And if you actually do a ChatGPT search on it, what you'll end up with is this document here, this set of comments here, that will describe the two engines that are living concurrently inside the tool. One is an autocorrelation engine, which identifies frequencies within a signal by comparing it with delayed versions of itself. So peak to peak to peak. And the second is the Fourier transform. So what the Fourier will do is it will generate the series based on what's discovered on the autocorrelation side. And those tools work together. It's really magnificent what they've done. That's item one. Item two is, you know, we're using natural values here. You really want to use natural log values to the base E. This is an example of looking at the natural log values. You can see that the curve is diminishing. Looking at the raw values, it would appear that the curve is increasing. So there is a benefit to going a little deeper than what we've illustrated. Go back to our lesson plan objectives. Okay, so we've talked about the underpinnings, the log values. Let's do a summary. Let's do a quick summary. You know, as we talked, you know, very good data sources and results are available from conventional low-cost tools. The only admonishment here is make sure that the juice is worth the squeeze. If you've got EBITDA impacting activities, it's worth your while to chat with people that might have had some experience. So that's where we are. Thank you for signing on and listening.